Assalamualaikum to Madam Fatima. My name is Muhammad Zafri. I'm represent for my team, Group 1 for Dijkstra algorithm. So I will explain about Dijkstra algorithm, how it works, and where the algorithm is used in the real world. So firstly, I will explain about how the algorithm works. So first, the Dijkstra algorithm start with the source node and analyze the complete graph to find the shortest path between the node and all of the other nodes in the graph. The algorithm keeps track of the currently recognized shortest path between each node and the source code and updates value whenever another shortest path is discovered. The node is marked as visit and can be added to the path once the algorithm has known the shortest path between the source code and another node. This process is being continued till all the nodes in the graph has been added to the path. As this way, a path gets created that connects the source node to all the other nodes following the plausible shortest path to reach its nodes. So this is how it works. So how the step-by-step process implement? First, the very first step is to mark all nodes as unvisited. So after we mark all nodes unvisited, we mark the peak starting node with a current distance of 0 and the rest node with infinity. Next, now fix the starting node as the current node. Continue. For the current node, analyze all of its unvisited neighbors and measure their distance by adding the current distance of the current nodes to the weight of the edge that connects to the neighbor nodes and the current node. Next, if compare the recently measured distance with the current distance and assign to the neighboring nodes and make it as the new current distance of neighboring node. After that, consider all of the unvisited neighbors of the current nodes. Mark the current node as visited. If the destination node has been marked visited and stopped, and algorithm has end. And lastly, else choose the unvisited node that is marked with the least distance. Fix as the new current node and repeat the process again from step 4. So it will be loop until we reach the destination at the last. So we will try to solve a question. So we have a question here. We will use the Dijkstra algorithm to solve it. So this is a vertex. A, B, C, D, E is a vertex. So we will find the shortest path from vertex A to vertex E. So we will calculate how to find the shortest path. So firstly, you must make a table for easy for you to find vertex. Then A, B for vertex B, C for vertex C, D for vertex D, and E for vertex E. Next is initial. Initial is for their numbers, that how long the current, what we call the current distance. For we will see the current distance in initial. So next, so this question is asked to start from vertex A. So start from 0. So we know we start from A. So A should be 0. 0. So we know we start from A. Sorry for the bad writing because I'm using mouse. So it's okay, we continue. So when we start with A, the others initial for vertex B, C, D, it will be infinity. So next, from A, we can see that A can go to B and C. So we start from A. So we write the vertex A in here. So first we can see that A can go to B and C. So we start from B. So B 4A. So A to C is 3. So we will write A to C. So we write in C table 3A. So the rest we will write infinity. So we will go from B to C. We will compare which one is the smallest number from vertex B and C. So we can see 3A is smaller than 4, so we use 3A. I will use color. 3A is smallest, so we will use C to continue our calculation. So we use C, vertex C, for the next calculation. 3A, for we go through here C, and then next is we write the C. Next we will continue. For from C, we can see that it's only can go to D, and it cannot go to B or continues to E. So we continue to D. So we continue from A to C, and C only can go to D. So before we put B, we must add 3, because we start from A to C to D. So the A to C is 3 and C to D is 4, so we must add it. So it will become 7 on D. 7C. So before that, don't forget about 4A, because 4A is not use it, because we still not use it. So we will drag down 4A to down. So we drag it down to 0 for A. So the rest, don't forget, the rest we will infinite. So compare 4 to C, 4 is smaller, so we will choose 4. Smaller than 7, so we choose 4. So 4 is from B. So next we will use B vertex. So from B, it's only going to go to D. As you can see, A, B and D. So we must calculate 4 plus 8. So 4 plus 8 equal to 12. 12B. But don't forget about 7C. 7C is still not being used, so we must drag it down to here. So let me correct it. B 7C. Okay. So don't forget about infinite for the rest vertex. So between 12 and 7 is smallest, so we will highlight the 7C, because 7 is smaller than 12. So So we click 7C. Come from ACD. So 3 plus 4 is 7. This way we got 7C. So 7C must plus with 7 to complete to E. So next is 7C. Which the mouse? 7C is on D. So we will write D on the column here. So D, 7C plus 7, 3, 4, 7. 3 plus 4 is 7C, and plus 7 is 14. So 14 at here. Oh, where's my class mouse? So we already finished our calculation. So we will write the shortest path. Shortest path. So we must calculate it from backwards. For we calculate it from 40D. So 40D is from D. 40D is from E. Sorry, it's from E. So starting from E, then we will see to here, D to C. So before that we write the D first, then D to C. So from C go to A. So A. So we got our shortest path ACDE. ACDE. So for the length, calculate it. 3 here plus 4 here plus 7 here equal to 14. So we got our answer here. So the shortest path from vertex A to vertex E is ACDE. So it will be like this. From A to E. So as other than that, Dijkstra algorithm also can be used in reverse. So for example, Dijkstra algorithm used in digital mapping service in Google Maps. So Google Maps use Dijkstra algorithm to show us the rough path to go to the destination in the shortest path and faster way. So we can see here example. So as we can see from Johor to Kelantan, there are many different paths and we can follow. So here by a car, we have 1 road, 2 road and 3 road that we can follow. If we follow the first road, it's only 693 kilometers and 8 hours and 59 minutes. That's the road path. If we estimate that if we will arrive the destination in 8 hours and 59 minutes. Next road is from Johor, we go to Kuala Lumpur and through the Tremolo. It's 909 kilometers and it's 10 hours and 22 minutes, which so far and link. And next we have 764 less than using Tremolo, which is 9 hours 23 minutes. From Johor we go to Kluang and we will go through quality paste, color kerai, and so on. So as we can see here, Dijkstra algorithm is involved in this calculation of GPS. So from any road we can go to the one destination faster and shortest path. So this is an example from Google Maps. And then next is social networking application. You may have noticed that this is in a variety of application. The app recommends a list of friends that a specific user may know. How do you think many social media companies will eventually implement these features, especially given that the system has over 1 billion users? The standard Dijkstra algorithm can be used to determine the shortest path with the user based on handshake or connection between them. It uses the standard Dijkstra algorithm along with several other functions to find the shortest path. However, as the graph grows larger, the standard algorithm takes several seconds to count and alternate change algorithm are used. So for the graph we see, Sarah has a connection with Felix and Sam. So when they have connection, so Sam has connection to Dave. So Felix can know Dave in the shortest seconds, because it's in a small connection. If the larger, it takes several seconds to know it. So this is the example. Next is robot vacuum cleaner. Those and robots are not available in Malaysia, some of which are manual and some of which are automated. The automated drones or robots that are used to deliver packages to specific location or for a task are loaded with algorithm modules, so that once the source and destination are known, the robot or drone move in the order direction by taking the shortest path possible to deliver the package in the shortest amount of time. Robot vacuum cleaners use this algorithm so that the robot can specific room using the shortest path. So as you can see, vacuum bot is using the Dijkstra algorithm to plan to clean the room by the shortest path. So usually, firstly, the vacuum robot will go around the room from B to A to C, C to D, F, H, and so on. You will go around the room and you will memorize every room and every path. So by the time the robot has collected all the information about the room, the robot will use the Dijkstra algorithm to clean the room using the shortest path. So as you can see, the Dijkstra algorithm is implemented in the robot, in the vacuum cleaner. So as we can see, Dijkstra algorithm is used in many applications, device, and so on. So by this video explanation on how to use the Dijkstra algorithm and where the Dijkstra algorithm used in real life.